Hello, let us discuss a few problems on three-phase synchronous generator. Okay, a three-phase 4-pole 50 Hz star-connected alternator has 36 slots and 30 conductors per slot. The useful flux per pole is 0.06 Weber. Find synchronous speed and line voltage on no load. Assume the winding factor as 0.96. So in this example, they have given number of poles as 4 and the supply frequency F is 15, and if the windings are star connected, then the alternator has 36 slots and there are 30 conductors in each of the slot. So we can calculate the total number of conductors by multiplying these two factors. Number of slots into number of conductors will give us the total number of conductors. So total of number of conductors, let us represent as Z, and it is in this case 36 into 30 is 1080. The useful flux per pole is 0.06 Weber. They have given. We need to find the synchronous speed, that is Ns, and the line voltage E line on no load. Okay, so here we have derived the expression for the EMF, which is 4.44 times phi f into TPH, and Kc Kd is called as a coil span factor and then distribution factor. The product of Kc and Kd can be taken as winding factor. Okay, so they have given the value of winding factor as 0.96. So let us use the equation as Ns is equal to 120 F by P to find the value of synchronous speed. So they have given supply frequency as 50, number of poles as 4. So we will get the synchronous speed as 1500 RPM. Okay, and so let us use this expression for EMF to find the phase voltage first and then the line voltage. So since they have told the windings are connected in the form of star, we know that EP is equal to √3 times of E line. So which is nothing but this one. E line is √3 times, E line voltage is equal to √3 times of phase voltage. That is EL is √3 times of E phase. Okay. So first calculate the phase voltage, that is EPH, which is 4.44 times Kc Kd, that is winding factor, into flux into frequency into number of turns in each phase. Okay, so in order to calculate this number of turns in each phase, let us make use of this expression. Okay, number of turns in each phase can be calculated by using number of conductors in each phase divided by 2, because we know that there are 2 conductors in a single turn. Okay, so the conductors in a single phase can be calculated by using number of conductors in single phase divided by 2. So first let us calculate ZPH, that is number of conductors in each phase. We know that there are Z number of total conductors and it is a 3-phase system. So we have to distribute 1080 conductors in 3 phases. So the conductors in each phase, that is ZPH, is number of conductors, that is Z, divided by 3. If you do, we will get 360 as the conductors which is being distributed in each of the phases. Okay, right. So now this ZPH, that is conductor in single phase, by 2 will gives us the total number of turns in a single phase. Okay. Okay, right. Now let us substitute all the values in the expression for the phase voltage, that is 4.44 into Kc Kd is 1 and flux is 0.96 Weber frequency is 50, sorry, TPH is 180, so we will get the value of EPH as 1918 volts, and the line voltage is √3 times EPH, will get 3.32 kilovolts. Next, let us take another similar problem. A 12-pole 500 RPM star connected alternator has 48 slots with 15 conductors per slot. The flux per pole is 0.02 Weber and it is distributed sinusoidally. The winding factor is 0.97 and pitch factor is 0.98. Calculate the line EMF. They are telling. Line EMF is again line voltage. EL we have to calculate. In order to calculate EL, we have to calculate EPH first. Okay. So we need to make use of this. So let us note down that whether we have all the parameters. So we have number of poles as 12, speed is 500 RPM, and 48 slots and 15 conductors. So let us calculate total number of conductors Z as 48 into 15, which is 720. And in each phase, we will divide this total conductor divided by 3, which gives to 40 conductors in a single phase. Okay, and the number of turns in a single phase, we can take this conductors in a single phase by 2. So 120 phases in a single 120 turns in a single phase. Okay, now also they have given the value of distribution factor KD and the coil span factor KC. Okay, so we will substitute all these value. We will get the phase value as 506.48 volts, and the line voltage is, if you multiply this 506 volts with √3, we will get the line voltage. So next, let us take another similar problem. Okay. A 2-pole 3-phase alternator running at 3000 RPM and it has 42 slots and 2 conductors in each slot. Calculate flux per pole. So 5 we have to calculate, which is required to generate the line voltage of 2300 volts, and the distribution factor as 0.952 and pitch factor is 0.956. Pitch factor is KC, distribution factor is KD. Okay, so let us note down all the values and calculate the frequency first using the synchronous speed relation 120 F by P. So we know the speed and number of poles they have given, so we can calculate the F. In this case it is 50, and if EH is equal to EL by √3, so line voltage they have given as 2300 volts. So let us take that divided by √3 will give us the phase voltage as 1327 volts. Okay, so the total number of conductor is Z, which is obtained by multiplying slots and number of conductors in each slot. So ZPH is Z by 3, which we get 28. TPH is ZPH by 2. It is 14 in this case. I already explained these terms. And substituting all these values, will get the flux as 0.46 Weber. So like this, we can find the known parameters for the 3-phase alternators. Thank you.